Welcome everyone to this 13th lecture of states of matter. In the previous classes, we have started with our liquid state of matter. We have studied about the properties of liquid, and we have also studied the some other quantities which are associated with liquid, such as volume, density, compressibility, and diffusivity. In today's class, we are going to delve deeper into some other properties of liquid. Okay, so let us write this down. States of matter, lecture 13. So the property which we are going to study today is vapor pressure. Vapor pressure. So as already discussed, if a liquid is placed in an open vessel, the molecules of the liquid escape from liquid to the atmosphere. On the other hand, if a liquid is allowed to evaporate in a closed vessel, the molecules escaping from the liquid surface do not leave the container. These are collected in vapor state above the surface of the liquid. Due to evaporation, liquid changes into vapors and the level of liquid decreases. After some time, the level of liquid does not change further and becomes constant. This behavior of liquid can be easily understood. Okay. In order to understand this, let me drag a picture. Right. So let us understand this picture. So initially, let us consider this is system A, this is system B. So initially, the system contains only liquids, right? So let us understand evaporation in an open vessel and closed vessel. So when the liquid, the container which contains the liquid is exposed to exposed to the atmosphere, the molecules of the liquid goes from a liquid to gaseous state. Whereas when we close the container, then the molecules of the liquid goes into vapor state and an equilibrium is reached, and that is what is called as vapor pressure. So in order to understand this, let us study this picture. So initially the system contains only liquid, right? And the space above the liquid is completely vacuum, right? As evaporation starts, the molecules from the surface of the liquid escape in the vapor state, and therefore the level of the liquid falls. The molecules which escape from the surface of the liquid gets confined to a limited space above the liquid. These molecules move randomly in all directions and collide with one another and with the walls of the container and with the liquid surface. During this, some slow moving molecules collide with the surface of the liquid and may be recaptured by the intermolecular interactions and get converted into liquid. This process is called as condensation. In the initial stages, the rate of evaporation is more than the rate of condensation because only a small number of molecules are present in the gaseous state. Therefore, the rate of condensation gradually increases as the number of molecules in gaseous phase increases. Finally, a stage is reached when the ratio of evaporation becomes equal to the rate of condensation. In such a state, the system is not at rest, though there is no change in the system because of the amount of liquid level in the vessel does not change. This does not mean that the evaporation has stopped. In fact, the number of molecules which escape from the liquid to the gaseous phase due to the evaporation becomes equal to the number of molecules which return to the liquid from the gaseous phase. Therefore, the amount of liquid becomes constant, and this state is known as dynamic equilibrium. This is the condition when two opposing processes occur at equal rate. The molecules in vapor phase exert pressure as the evaporation reaches equilibrium state. The concentration of the molecules in the vapor state becomes constant. The pressure exerted by the molecules in the gaseous phase in equilibrium with the liquid is called as equilibrium vapor pressure, right? Which is also called as vapor pressure. Hence, vapor pressure may be defined as the pressure exerted by the vapors in equilibrium with its liquid at a given temperature. Right? So let us write this down. So vapor pressure can be defined as the pressure exerted by the by vapors in equilibrium with its in equilibrium with its liquid at a given temperature. This is called as saturated vapor pressure. Right? The vapor pressure is a characteristic property of a liquid. The vapor pressure is a characteristic property of a liquid at a given temperature. It does not depend on the amount of liquid. It does not depend on the amount of liquid or the vapor phase. The magnitude of the vapor pressure depends upon the following factors. The magnitude of vapor pressure depends upon the following two factors. These are number one, nature of liquid and temperature of liquid. Right? So let us understand the first one in detail, which is nature of liquid. The vapor pressure of a liquid depends upon the nature of the liquid. When intermolecular forces are weak, the molecules tend to escape readily, and therefore the equilibrium vapor pressure is high. Right? When intermolecular forces are weak, the molecules tend to escape readily, and therefore the equilibrium vapor pressure is high. Right? Therefore, the vapor pressure of liquid provide an indicative of the magnitude of the intermolecular forces. Therefore, the vapor pressure, therefore, the vapor pressure of liquid provides an indicative of the magnitude of intermolecular forces. As mentioned previously, either ether and alcohol evaporates faster than water, and hence we would expect that ether and alcohol to have a higher vapor pressure than at a given temperature. The high vapor pressure of ether and alcohol as compared to water is due to the fact that there are weaker attractive forces in ether and alcohol as compared to water. Right? What we can write is, we can write that lower the, okay, so this is it. So for example, ether and alcohol have higher vapor pressure than water. Right? That means higher vapor pressure means lower intermolecular forces, which means that easier to evaporate. Right? Second one is the temperature of the liquid. The vapor pressure of liquid decreases with increasing temperature. The vapor pressure of liquids decreases with increase in pressure. As temperature increases, the fraction of molecules having larger kinetic energy increases. Therefore, more molecules escape from the surface of the liquid, and therefore the concentration of molecules in the vapor phase will increase. Hence, vapor pressure of the liquid increases. Okay. Let us write this down. As the temperature increases, the fraction of the molecules having larger kinetic energy increases. Larger kinetic energy increases, and hence the fraction of molecules having larger kinetic energy increases. Right? The third point is, therefore more molecules escape from the surface of the liquid. Right? Therefore, concentration of molecules in the vapor phase will increase. Concentration of molecules in vapor phase will increase. Right? Hence, vapor pressure of liquid increases. Hence, vapor pressure of liquids decreases with increase in temperature. Also, it has to be increase in temperature. So the next point is the boiling point. Boiling of liquid. Next property which we are going to study is boiling. We have learned that the tendency of molecules to escape from liquid to gas phase is measured by the vapor pressure. It increases with rise in temperature of the liquid. When the temperature of the liquid is gradually increased, its vapor pressure also increases. And ultimately, a stage is reached when the vapor pressure of the liquid exceeds the vapor pressure of the air above it. At this point, not only molecules escape from the surface, but the vapors formed within the liquid can easily rise to the liquid in the form of bubbles and escape. This phenomena is known as boiling, and the temperature at which this occurs is called as boiling temperature. Right? Hence, therefore, a boiling point is the temperature at which vapor pressure of a liquid becomes equal to the atmospheric pressure. Okay? So, boiling point, the temperature, let us understand this term. Boiling point is the temperature at which boiling occurs, and boiling, and what does that mean? What does boiling occurs? That means boiling point is the temperature at which the vapor pressure of a liquid, the vapor pressure of liquid becomes equal to the atmospheric temperature. The boiling point therefore depends on the atmospheric pressure, right? The boiling point thus depends on the atmospheric pressure, right? As the atmospheric pressure increases, it is necessary to heat the liquid to higher temperature to make its vapor pressure equal to atmospheric pressure. As the atmospheric pressure increases, it is necessary to heat the liquid. It is it is necessary to heat the liquid, and it is necessary to heat the liquid, right? Heat the liquid to higher temperature, temperature to make its vapor pressure equal to make its vapor pressure equal to atmospheric pressure, right? However, the boiling point changes with change in the pressure above the liquid. At high altitudes, atmospheric pressure is low, and therefore liquid at high altitude boil at a lower temperature in comparison to sea level, right? So at high altitudes, atmospheric pressure is low. Atmospheric pressure is low, and therefore liquids at high altitudes boil at lower temperature in comparison to sea level. Thus, at high altitude, water boil at a much lower temperature than in at a surface, right? Since water boils at low temperature on hills, the pressure cooker is generally used for cooking food, right? Generally, boiling point for most of the liquids are specified as normal boiling points, and the normal boiling point of a liquid is the temperature at which the vapor pressure of liquid becomes equal to 1 atmosphere. Right? So, sixth one is our definition of normal boiling point. The normal boiling point is the temperature at which the vapor pressure of liquid becomes equal to the 1 atmospheric pressure. So 1 atmospheric pressure. Right? If the pressure is 1 bar, then the boiling point is called as standard boiling point. If the pressure is 1 bar, then the temperature is called as standard boiling point. Right? Standard boiling point of liquid is slightly lower than the normal boiling point because 1 bar pressure is slightly less than 1 atmospheric pressure. Right? Standard boiling point of a liquid, boiling point of a liquid is slightly lower than the normal boiling points. Normal boiling point because 1 bar pressure is slightly 1 bar pressure is slightly lower than 1 atmosphere pressure. Right? Effect of so the next topic which we are going to study is effect of change in external pressure on the boiling point. Effect of change in external pressure on the boiling point. Right? A liquid may be uh, a liquid may be made to boil at any desired temperature by changing the external pressure. For example, a liquid may be made to boil at lower temperature than the normal boiling point by reducing the external pressure, or it may be made to boil at higher temperature by increasing the pressure. It is observed that some substances decompose at their normal boiling points and therefore they cannot be heated up to their boiling points. They are made to boil at reduced temperature. This principle is used in purifying less stable liquids by distillation under reduced pressure, and this process is called as vacuum distillation. It may be noted that once the boiling starts, the temperature of the liquid remains constant even though heating is continued until the whole of the liquid has been vaporized. Right? So let us write this down. A liquid may be made to boil, may be made to boil at lower temperature, at lower temperature than a liquid may be made to boil at any desired temperature, at any desired temperature, any temperature by changing the external pressure, by changing any desired temperature, by changing the external pressure, right? It is observed that some substances decompose at their boiling points and therefore they cannot be heated up to their boiling points, right? They are made to boil at reduced pressure. They are made to boil at reduced pressure. And this principle is used in purifying less stable liquids by distillation under reduced pressure. And this process is called as vacuum distillation. Right? Another thing which has to be noted is that it may be noted that once the boiling starts, the temperature of the liquid remains. The temperature of the liquid remains constant, even though heating is continued. Heating is continued until the whole of the liquid has been vaporized. Until the whole of the liquid is vaporized. Right? When the liquid, the reason for this is when the liquid is heated, the heat is supplied to pull the liquid molecules apart against the strong attractive forces which hold them together in the liquid form. Thus, the heat energy goes to compensate the loss of energy due to escaping molecules which have to overcome the attractive forces between the molecules of the liquid. As a result, there is no change in the average kinetic energy of the molecules remaining in the boiling liquid, since the average kinetic energy is proportional to the temperature. Therefore, the temperature of the liquid does not change until the whole of the liquid has been converted into vapor state. The reason for this is as follows. Right? When the liquid is heated, when the liquid is heated, the heat is supplied to the heat is supplied the heat supplied sorry the heat supplied the heat supplied is consumed to pull the liquid molecules apart against strong attractive forces strong attractive forces which hold them together in the liquid form, right? Thus the heat energy goes to compensate the thus the heat energy goes to compensate the goes to compensate the loss of energy due to loss of energy due to escaping molecules which have to overcome the which have to overcome the attractive forces between attractive forces between the molecules of the liquid, and hence as a result there is no change in the there is no change in the average kinetic energy average kinetic energy of the molecules of the molecules remaining in the boiling liquid remaining in the boiling liquid, right? Since the average kinetic energy since the average kinetic energy is proportional, it is half mv square proportional to temperature. Therefore, the temperature of the liquid the temperature of the liquid does not change till the whole of liquid has been converted has been converted into vapor state. Vapor state. Boiling does not occur when the liquid is heated in a closed container, right? On heating continuously, the vapor pressure increases, and at first a clear boundary becomes visible between the liquid and vapor phases because liquid is more denser than vapor. But as the temperature increases, more and more molecules of liquid goes to vapor state, and as a result, a density of vapor phase increases. At the same time, liquid becomes much less dense and expands because molecules move apart. When density of the liquid becomes equal to the vapor phase density, a clear boundary between liquid and vapor disappears, and this temperature is what is called as critical temperature, which we have already learned, right? Let us write this down. Right? Boiling does not occur when a liquid is heated. When a liquid is heated in a closed container, right? On heating continuously, on heating continuously, vapor pressure increases. Vapor pressure increases. At first, a clear boundary becomes visible. A clear boundary becomes visible between liquid and vapor phase. Between liquid and vapor phase because liquid is much more denser than vapor. Because liquid is more dense than vapor, right? But as the temperature increases, but as the temperature increases, more and more molecules of the liquid, more and more molecules of the liquid go to the vapor phase. Go to the vapor phase, right? As a result, density of the vapor phase increases. As a result, the density of vapor phase increases. At the same time, liquid becomes less than. At the same time, liquid becomes less dense and expands because molecules move apart. Molecules move apart, right? Molecules move apart. When density of the liquid and vapor becomes the same, when density of liquid and vapor becomes the same, the clear boundary between liquid and vapor disappears. The clear boundary between the clear boundary between liquid and vapor disappears. Between liquid and vapor disappears, right? This temperature is called as critical pressure, right? This temperature is called as critical temperature, which we have learned already. Learned, right? Now let us try to understand the difference between evaporation and boiling. Difference between evaporation and boiling, right? So let us write here evaporation and here write boiling. First point here is evaporation pressure. Evaporation process takes place simultaneously at all the temperatures, whereas boiling takes place only at a definite temperature, which is known as boiling point, at which the vapor pressure of the liquid is equal to the atmospheric pressure. So evaporation process takes place spontaneously mostly at all temperature, whereas boiling takes place only at only at definite temperature, definite temperature at which the vapor pressure of the liquid vapor pressure of the liquid becomes equal to the atmospheric pressure. Atmospheric atmospheric pressure. Okay. The second point is evaporation takes place only at the surface of the liquid, whereas boiling takes place even below the surface of the liquid in the form of bubbles. Evaporation takes place only at the surface of the liquid, only at the surface of the liquid, whereas boiling takes place boiling takes place even below the surface, even below the of the liquid, surface of the liquid in the form of bubbles, in the form of, right? The last property which we are going to study is the surface tension, right? So surface tension is defined as it is defined as it is defined as the force per unit length acting perpendicular to the tangential line drawn on the surface of the liquid, on the surface of the liquid, and surface tension is denoted by Greek symbol gamma, right? This gamma is denoted as this, right? And the unit of surface tension is unit of surface tension is Newton per meter, as it because gamma is nothing but force per unit area, force per unit length, right? So in this class we have studied the other well-known properties of the liquid, such as boiling, evaporation, vapor pressure, and surface tension. So with this we have completed this chapter, and I hope that you have learned good things from this chapter, and I hope to see you all again in the next class. Thank you all for attending this class.